الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على رسول الله سيدنا محمد وعلى آله وصحبه وسلم أجمعين. ما بعد. اللهم علمنا وانفعنا بما علمتنا إنك أنت عليم حكيم. So we are still in this section of partial derivatives. We took it the previous lecture. We reminded ourselves about the derivative of single value function, which is given this way, and hence the derivative of or partial derivative of f with respect to x is given in this limit. But notice that we're putting h in the x component. If I want to find the derivative with respect to y, I put the h component here. If I want to calculate the derivative or partial derivative using the limits, this is a derivative, partial derivatives at a certain point. But if you want to find the partial derivative as a functions, you can go with these limits here. And the notations, we said that partial derivatives, we can write d, the usual d by dx of f, but notice here we're putting y as a constant, y naught, and we differentiate respect to x. Just substitute every x by x naught, or we write the notation, which is this is the more popular, partial f by partial x, or some people they call it df by dx, evaluated at x naught, y naught. Sometimes if z equal f, we can write it this way, or we use subscript. Also, this is another popular notation for partial derivatives. So it means partial f by partial s, so the derivative of f with respect to x, evaluated at x naught, y naught. Sometimes we put z there. And all equal, they're all the same. Similarly for the variable y, which is given this way. And the calculation, we said that, well, if you want to find the derivative of f with respect to x, you just think y as a constant and differentiate with respect to x, as you learn in Math 101. Similarly, if you want to find the derivative with respect to y, then you need to think of x as a constant and differentiate with respect to y as using the rules of differentiation in Math 101. We solved this example, is very basic thing, and we solved this one, it's very easy. All of these examples, we solved them. And here in the example number 4, we'll learn the implicit differentiation. Sometimes we need to do it, so it is very easy. You can do it. Next, we're going to talk about the geometric interpretation of the partial derivatives. And before I present here, let me bring this thing. I'm going to use GeoGebra, and I feel this is way better than giving you just the sketch or the figure. So as you see here, Shabab, what is this? You have exam today and quiz just after minutes. What we call this? This is the equation of the surface. 4z equal x squared plus y squared. What we call it? Square on x, square on y, between the plus and z is the other side. What do we call it? Yes?
We see nothing. We don't see anything.
You did not see anything. Like, okay, maybe okay, what about now? Okay, maybe I shared only the PowerPoint. Okay, yeah. So now, 4z equal x squared plus y squared. What does it give? Square on x, square on y, but there is plus, there is no square on z. Yes, Rakan? Mumtaz, elliptic paraboloid. Very good. So it gives elliptic paraboloid. But actually, it's not elliptic because you divide it. This is 4. When you divide by 4, you will get kind of a circular elliptic paraboloid. Yeah. But anyway, so we have this shape. Okay. Now, I want to know what does the derivative mean, or the partial derivative means on here. Okay. So let's pick a point, and I'm picking the point 2, 2, 2. Okay. This point 2, 2, 2, it's on the plane. You can check it. If I substitute x by 2, y by 2, so you get 4 plus 4, which is 8. If you divide by 4, you will get z equal to. Okay, so this point, as you see here, it is point on the surface. Okay, it is a point on the surface. Okay, fine. Now, this is the point 2, 2, 2, 2. I want to draw a plane y equal to. A plane y equal to, and this point, if you look here, I'm taking the y coordinate and I'm going to draw a plane y equal to. Okay, y equal to. And I ask myself, what is the intersection between this plane and this elliptic paraboloid? And if we do that, we have, if you see this blue curve going like this, this is the blue curve. Huh? You see, this is the blue curve here. Okay, So if I look at it from this way, you can see it now. This is the blue curve, the intersection between the plane and the elliptic paraboloid. Now let me remove the plane, these planes. Now you see, this is the result, the intersection between the plane and the elliptic paraboloid, and this is the point A. Okay, now we have a curve in 2 dimensions. We have a curve in 2 dimensions, a curve in the plane. Yeah, you think of this like for example, if you think of it as x-axis, and this is y-axis or z. Actually, it is z. Yeah, z or x, and you have a point. When you differentiate the partial derivative, we say keep y constant, but I differentiate with respect to x. So what does it give in this case? It gives, let me have it. Yeah, it gives the slope of the tangent line. Yeah, imagine this is a plane. You are working on a paper. You have this curve. When you find the partial derivative with respect to x, at this point, in fact, you'll find the slope of this tangent line. Okay, we are working on the plane on like 2D here, Shabab. Huh? Is it clear so far? Is there any question? This is partial f by partial x. Partial f by partial x evaluated at the point AB. Keep in mind, we are fixing y, yani y constant. That's why we are thinking of 2D, 2 dimension. So that's why we have this line. But of course, if I rotate, the line is 3-dimensional. But in this plane, just if you're looking like this, this is 2D. This is x-axis, like y-axis, but actually it is z-axis. So you have the equation of the line. Right. This is for partial f by partial x. Now, let's do the same thing. Let me remove these guys here. This is a point A. The first case, we put the plane y equal 2. Now, let's put x equal 2. Okay, x equal 2. So it means that I'm making x constant. Okay? And then let's find the intersection. Oh, no, not this one, actually. So this is the intersection point. Okay, if you look here, this is the intersection between the plane x equal 2 and the surface. Okay, if you look at here. Now let me remove the surface. Let me remove the plane. Okay, sorry. Let me remove this. And yeah, so we have the point. And okay, you have the point, and okay, I think I made a mistake here. No mistake here. Okay, very good. So we have it here. Yeah, still we have it here. Yeah. So we have the point and this curve, and if I want to find the derivative with respect to y, evaluated at this point. Now think the green line, Shabab, the green axis is the y, the blue axis is the z. Yeah, y is it, but still you are looking as 2 dimension. When you find derivative at this point, Shabab, you will have this line. You have this line. You see the black line here. So this is like the tangent line. So the derivative evaluated at this point, the derivative with respect to y evaluated at this one, is the slope of this tangent line. So if you look here, a line is actually a line in 3 dimensions, but this is, if I look in 2 dimensions, this is the slope of this tangent line. Okay? Any question here? Right. So if you look at the geometric interpretation, this is what it looks like in the textbook. The partial f by partial x evaluated at x naught, y naught is the slope of the tangent line to the curve z equal f x. Notice here, Shabab, we're putting y naught. Yani we are thinking of a function of one variable, z equal f x, at the point p x naught, y naught, f of x naught, y naught in the plane y equal y naught. This is for the case if you're fixing x. So the partial f by partial y is the slope of the tangent line to the curve z equal f x naught y at the point this in the plane x equal x naught. Okay. So we saw it in the program, in the software, but this is what they really are. Okay. Now let's talk about the functions of more than 2 variables, because so far we are differentiating functions only with 2 variables. What will happen if I have more than 2 variables? So the definition works the similar way for functions of 3 variables, for example, or any number of variables more than 2. So, for example, if I have a function of 3 variables, x and y and z, I want to differentiate with respect to x. In limits, in definition, just put h here, x plus h over h here, okay? And in general, if u is a function of n variables, in future, Shabab, you may deal with functions of more than 3 variables. So if you want to calculate the partial derivative in the I variable, xi is, look at the xi here, you see, this is the xi, I add h here, so over h. This is the definition. But how I can run the calculations? The calculations like what we did in 2 variables, meaning that, for example, in 3 variables here, if I say fx, x, y, z, meaning that I differentiate with respect to x and think of y and z as constants. Think of y, z as constant. And similarly, you want to find the derivative of f with respect to y, meaning that differentiate y, as I know in MATH201, but x and z, I think of them as constant. Inshallah, if you have 100 variables, if I'm saying u, partial u by partial one of these variables, that variable I consider it, everything else I think of them as constant. Okay? So in terms of calculation, we treat xi as a one variable and all others as constants. So for example, if I want to find partial derivative with respect to x and then with respect to y and then with respect to x for the function this, what we do, ya shabab, what is the partial f by partial x? Well, I see here x, ya shabab. This is x, the variable. If you look sine y plus 3 z, هذه كلها constant. This is all constant. So what is the derivative of x times sine, ya shabab, with respect to x? Anyone? What is the derivative with respect to x of this function? I don't need to write it in paper, I think it's clear.
1.
1. Any other answer? What is the derivative of this function, I mean? The derivative of the whole function with respect to x. What will be? 1? Okay, I see answer in the chat. Okay,
Actually, sine y plus 3z.
Okay, very good. So this is it. Sine y plus 3z. Derivative with respect to y, if you see there is y inside here, so we differentiate with respect to y, you get cosine y times the derivative inside, but the z is constant, so you have x there also. So you have everything. Differentiate with respect to z, this is z here, so you have to multiply by the derivative of this y plus 3z, which is 3, so you have the derivative of this y here, okay? Some of you said we use the definition. Yes, originally we need to use the definition, but you see that we don't need to go through the definition. We want to use the rules and all of these guys, so we use the same thing here. Okay. Any question here, Shabab?
Sir.
Yes, Rakan.
It's important to know the definition. يعني ممكن يجي سؤال for the definition.
Sometimes yes, sometimes you need to some derivatives, and there is an example, but I didn't put it here. It's better to go through the definition. Okay, but it depends. But most likely, most of the case, most 99% or 90%, let's say you will use the rules. Okay, right. Now let's talk about the higher derivatives. As you saw, all derivatives are first order, but what about if I'm gonna have a second order, third order, and so on? What should I do? So let's start with the second order. If you have a function z equal f of x and y, function of 2 variables, and I want to find derivative of second order derivative, we write this way: fx, and then between brackets x, it meaning that I'm gonna differentiate the partial derivative with respect to x. So I'm differentiate with respect to x of the first partial derivative with respect to x, and we're gonna write fxx, xx, meaning that I'm differentiate with respect to x, and then again I differentiate with respect to x. Or we use the Leibniz notation, which is partial by partial x of partial f by partial x. Here meaning that I'm differentiate with respect to x of this function, which is the first derivative of f with respect to x. And we simplify it this way, like we learned in MATH201. 2, 2. You remember, like d2f by dx squared with the same thing, partial 2f by partial x squared. And or if we want to replace f by z, that's fine, because we are saying z equal. So this is what you have here. Now, not only that, you might have what we call the mixed derivatives. Mixed derivative. يعني for example, I have derivative of f with respect to x, and then I want to differentiate. No, I want to differentiate with respect to y. So we have partial f by f, and then by derivative with respect to y. So we write it this way, f x y. And we write it this way, partial by partial y, partial f by partial x. And here, Shabab, please, it is important to know the order for the now, but later we will see that it is okay. But for now, just to see the order, how to read it, we differentiate with respect to x. If you see here my pointer, f x y, meaning that I differentiate with x first, and then I differentiate with respect to y. And I start from the left here on the subscript. I start x, differentiate with respect to x, and then I differentiate with respect to y. But if I want to write it in Leibniz notation, like fractions like this, I will write partial f by partial x. So meaning that I differentiate with respect to x, and then I differentiate with respect to y. Or we write it this way, d2f dy dx. But keep in mind, when I put dx here, meaning I differentiate x first, and then I differentiate y. I differentiate with respect to x first, and then I differentiate with respect to y. Okay, and similarly here, we're just replacing f by z. What about the other way around? You can say have it. So fy x, so meaning that I differentiate with respect to y, and then I differentiate with respect to x. So you can write it this way, you can write it this way, and notice how you order the d's down. So I order dy and then dx. I start from right to left. Here, left to right. Okay, dy and then dx. So do it this way, and then of course we have derivative with respect to y. So we have fyy. Here it's so easy that we can do it this way. So now if you see the second order derivative, we have many options. You can differentiate xx, xy, yx, yy. What about the third order? You can have a lot of options down this one. And you have fxxx, fxxxy, fxxyx, fxy x, and so on. You think of all possibilities, and the fourth derivative, and so on. Okay? So, and then here is the question. If I'm differentiating with respect to x and the y, and I differentiate y with respect to x, does this give the same answer or different? Because here we see I'm emphasizing on the order. Does it mean that the answer always will be the same or will be different? Someone answered this question, which is his name is Clairaut in English, but in French they call it Clairaut's theorem. By the way, I'm not French and I do not speak French, but this is why I heard Clairaut's theorem, and he said this: suppose f is defined on a disk, yani it has a certain domain that contains the points a, p. If the function fxy, fxyx, these second order derivatives are both continuous on this domain D, then they are equal. Then they are equal on this case. So meaning that if fxy and yx are continuous, then they are equal. I know this will be equal all the time. Okay, so in this case, if this fulfilled, it doesn't matter the order, fxy, yx, whatever. Okay, and of course this theorem applies in any order you want, not only in the second order. But in general, we can differentiate any order as long as they are exist. For example, if I want to go third order derivative, so I can have fyyx. If I want to go fourth order, fyyxx. Imagine all the possibilities you can do with the derivatives here. Okay. Any question here, Shabab? Right. So we have these, but keep in mind, Shabab, when I say two variables, we have, Abdurrahman, I'll come to you. So we have two variables, then it's second order. If you have like this written 3, it means third order, derivative of the third order. If I say how many written? 4, so it means fourth order. Okay, derivative of the fourth order, but of course you take the with respect to what you have to follow this order. Yes, Abdurrahman, تفضل.
دكتور الحين كيف بيكون الناتج حق مثلا ديريفيتيف للواي اول ثم الاكس؟ يعني هل بيكون الناتج بيكون فيه اكس واي او مثلا ممكن هم يطيرون؟
It could be. Maybe you go up to 10th order, still you have x and y. So it's fine. Okay. Or all the variables, still you have it there. Yani don't think that maybe when I do derivative I will get 0 at the end. No. Okay, it depends. Maybe some cases it will give you 0, huh? but or constant, let's say. But you can have anything in. Okay.
Okay.
So here is the question: find all the second order derivatives of this guy. Okay. So like, I want to do something actually. Yeah. And I will pick. No, it doesn't work. It doesn't work. Okay. Because we did it like this and. Okay. Right. Okay, so I have to stop doing it this way. So I have to stick the old style. يلا شباب. Find the old second order derivative. So when you say all, mean all the possibilities. Yeah. Okay. So what should we do, شباب? What we do. Well, let me write the function f(x) and y equal e x y. Okay. طيب, what should I do to find the second order? I have to find the first order. So we have to find the fx. What is fx? I differentiate with respect to x. What is derivative with respect to x? Anyone?
A to the power y.
A to the power xy times
multiply by y.
multiply by y. يعني think of y as a constant. Very good. And then f of y, I have to find the derivative of this one, which is x e x y. Okay? طيب. He said find all the possibilities. From here you have two possibilities. From here you have two possibilities here. Okay? So here we have xx. بعدين يا شباب ايش؟ xy. Right? So now fxx, what does it mean? I differentiate this with respect to يا شباب. What?
X.
X. طيب. So I have y here. Y is a constant. E to the power xy. So this is the only variable I have it here. Huh? So what will be the derivative? E
y.
xy times Rakan.
y y square.
Y square. Very good. Y square. Okay. Y square. So we're gonna differentiate. You're gonna multiply y again. So we have y square. طيب. Next fxy. fxy يعني I'm differentiating this, but now with respect to y. Now here يا شباب, if you notice I have y here and y here, so I have to use what?
Product rule. Product rule.
Product rule. So I will say first times derivative of the second with respect to y, keep in mind, it will be e x y times x plus derivative of the first, which is 1 times the second. So we have it this way here. Okay? And just keep it because there's nothing we can do. Now here, Shabab, let's do f y y. And next I will do fxy, yx. Okay? f y y. What is it? I have y here. So you are gonna have x e x y times derivative of the y in the exponent, which will be another x. So we have x squared. Right. Next, f y, which is the original one, and then I'm gonna differentiate with respect to x. Okay, so when I differentiate with respect to x, I'm gonna follow the product rule. Okay, so I will say first times derivative of the second. Derivative of the second will be y e x y. Okay, because of derivative of this one, plus derivative of the first times second e x y. Okay, now what do you notice here, Shabab? These two.
equal each other.
Equal, so f of x y is equal f of y x. And why this happened? Because this is continuous. When I know, Shabab, in fact, when I differentiate this many times, any way you want, you will have continuous. هذه continuous, هذه continuous, هذه continuous, هذه continuous. So I'm expecting even the second order derivative, whenever order you will do, you will get a continuous function. So I'm sure I'm going to have it this way. So the bottom line is this. When I say fxy, خلاص yx هو هذا نفسه. Okay, نفسه, can write it this way. Okay. طيب, so let's go to the next. Yeah, so we have these. Yeah, so find this one. Find this one. خلاص هذه we are done. So find this one. Here we have f x y z equal x cube y z square plus tan inverse of x square root of z. Okay. Now we need to find f x y z. Sorry, f x z y. ايش معناته يا شباب؟ I differentiate first with respect to y ولا z ولا x يا شباب؟ مين ابدا في الدرب؟ x هذه اول، بعدين z وبعدين
y
بعدين y وبعدين y. اوكي. طيب لما اسوي derivative respect to x يا شباب انا ما عندي مشكله هنا، بس هنا يا شباب you will get something complicated, right? Because derivative tan inverse is 1 over and then multiplied by square root z, so you get something complicated here. But notice this, there is no y here. ما في y. صح ولا يا شباب؟ So if I'm gonna differentiate x, z, y, and I know for the fact that يا شباب if I differentiate هذا الترم يا شباب whenever I differentiate x and y and z you always get continuous يعني polynomial في الأخير يعني multiple, so you don't have any problem. The tan inverse when you differentiate with respect to x it will be 1 over 1 plus something square, which is never be zero denominator, so we have continuity all the time. So you don't have any problem in the continuity of this one. So I can, instead of starting with x, I can differentiate starting with يعني reorder this. غير ترتيبه يا شباب. So I can start the differentiate with respect to, there is no y here يا شباب. So what should I start differentiate with respect to what?
y.
y. أول شيء أبدأ بالy. تمام؟ عشان ايش؟ عشان derivative of this one will be zero because of derivative of this one will be zero. هذه done. وهذه derivative very easy with respect to y or whatever. طيب بعد ما اخلص ال y what left is x and z. You can reorder any way you want. You can say xz for example. Okay. So this is equal to, or this is another option. You can say y z x نفس الشيء. Okay. كلها نفس بعض. ها؟ كلها نفس بعض. ها؟ So now. So let's differentiate with respect to which is this one. So let's differentiate with respect to y. Okay, so we're gonna have it. You can write it many ways. So we have partial 3, partial y, بعدين partial x, بعدين partial z of these guys. It's a matter of writing, and you can write it this way, which is equal to partial 2 by partial z partial x of يعني خلاص I'm gonna differentiate with respect to y. ايش الدerivative with respect to y? We said this is 0. This is with respect to y, so you have x cube z square. You know هذه constants وهذه y power 1, so you have it this one. And this is equal to partial by partial. Next one is z. Sorry, is x. So derivative with respect to x ايش يعطينا يا شباب؟ x square z square. بعدها يا شباب derivative with respect to z ايش يعطينا؟ 2 6 x square z. Okay, 2zx square z. Okay, شباب. So that's it. That's it for now. Even if you follow this one يا شباب يعني مثلا بدلت قلت لا I want to derive with respect to z هتقول 2x cube z and then differentiate with respect to x you will get this the same answer. Okay. Now you see this is a beauty of reordering the derivatives here. Okay, you can reorder them. Sometimes the calculation will be easier like this one. And if you want to follow exactly this order, it will be long way. If you look at the tan inverse derivative, when you have x here, it will be 1 over 1 plus this square multiplied by the square root of z, and then differentiate with respect to z, and then with respect to y, it will be complicated a little bit. But you notice that I'm differentiating y at the end. So whenever you're going to have it here, it will be 0. Okay, so that's why we bring y first. It's better for us. طيب, any question here, شباب? Okay. This is the end of this section 14.3,
دكتور
which is partial derivatives. Yes.
عندي سؤال بس بسيط.
Yes.
Now we can rearrange it to the easier way, the way we are comfortable with.
Yes. Yes. As long as you just guess or observe that you will have a continuous functions. Okay.
Okay.
Okay, because as I said here, you will have continuous, which is most of the case, most of the time it will be continuous. يعني do it يعني. Okay. خلاص يا فيصل.
خلاص.
Okay. طيب. So this is for the partial derivatives. The next one is about tangent planes. Still, I have a few minutes before we start the quiz. So it's about tangent planes and linear approximations. Of course, I'm not gonna finish everything, but at least we want to get the idea. So next lecture, next week we're gonna just move on to this one. So yeah, to explain the tangent plane, in fact, it's better to go through the software because I prepared it there. Can you see the software, Shabab?
Yes,
Yes,
Okay.
دكتور.
طيب. So let me don't know why it's not clicking. Yeah, alhamdulillah. Now it happened. طيب. Remember this is surface, the point, and then we have this plane, okay. وطلعت لنا two lines صح؟ عشان partial derivatives اللي هم هذول two lines. Let me remove the plane, let me remove the plane, let me remove the intersection. تتذكرون الشباب كان اصلا if you count these because we differentiate with respect to x and respect to y, I have one of them tangent line and I have another tangent line, which is this one. Is it clear يا شباب? Any question here? But I know if you notice what we did before, we got two tangent lines. Now the question is this: can we have a plane containing these two tangent lines? Can we have a plane that containing these two tangent lines? And the plane is this. And the answer is yes. If you look at this plane, Shabab, this plane contains the tangent line. And look at the plane, Shabab. If you look at the plane and the surface, you see the plane is touching the surface. I don't know if I can make it a good angle, but the plane is touching the surface at this point. Okay, touching the surface at this point. So the plane acts like a tangent line. And so this plane, we call it tangent plane. Tangent plane, okay? So the tangent planes, so we start with the surface z equal f of x and y. طبعا we are talking about three-dimensionally. Pick a point on the surface S, okay? We call it S, the surface. Let's have two curves, C1 and C2, obtained by intersecting the plane y equal y naught, x equal x naught in the surface, like what we did in the partial derivative just minutes ago. Then the point P lies in both curves C1 and C2, which is clear. And let T1, T2 be tangent lines to the curve C1 and C2. That's what we have seen before. Now the tangent plane of the surface S at the point P is defined to be the plane that contains both tangents T1 and T2. And here he made the sketch in the book, but I feel it is not clear as we cannot see it in three-dimensional space. The equation of the tangent plane is given this way. Of course, in the next lecture, I will show you why we have this equation, why it looks like this, how it's derived. But this is the formula for the equation of the tangent plane. Okay, Shabab? طيب, so we'll come back to this section. We'll come back to this section, and where is the teams? Yeah, but now we're gonna prepare for the quiz. So please just if you need to log on, off, whatever, just prepare yourself. I'll give you 5 minutes to turn on your cameras. Yeah, let me stop recording actually.